In this video, we're going to look at how to add and subtract rational expressions. So starting right here, we have a rational expression on the left, and we have this rational expression on the right. We want to add those, and so what we have to do is we can treat this basically like adding fractions. So if I have 6 over 15x, and I'm trying to add it to 7 over 5x squared, we need to get a common denominator. And so what the common denominator is going to be the least common multiple of the denominators. And so I know I'm throwing a lot of vocab terms at you. What I mean by that is let's find the least common multiple of 15 and 5, and then let's find the least common multiple of the variables. And then what I'm going to try to do is I'm going to try to create that denominator in both of these terms. And here's what I mean by that. If I could turn this 5 into a 15, then they would both have a denominator of 15. And so what I'm thinking is, what do I need to multiply 5 by to get a 15? And hopefully you're saying, well, all I need to do is multiply a 5 times 3 to get 15. Well, you'd be right. But I can't just multiply the denominator by 3. What we're doing is anything I do to the denominator, I have to do to the numerator. In other words, I'm really multiplying by what I call a fancy 1. Because 3 over 3 is equivalent to 1. And when you multiply something by 1, you don't really change its value. We're just going to make it look a little different. Okay? Now, by doing that, I would have the denominator, and I guess I'll copy it down below. What this would become was the numerator would be 7 times 3, which is 21, and the denominator would be 3 times 5x squared, which would be 15x squared. Well, this now has a denominator of 15x squared, and I got to think, what do I need to multiply this by to create 15x squared? And hopefully you're saying, well, you need to multiply by x, because x times x would give you that x squared, and you'd be right, but once again, I've got to multiply by 1. I've got to multiply by what I will always refer to as the fancy 1. Because whenever you do that, you don't change the value of your expression, because anything times 1 is just going to be itself. So in this case, my numerator is going to be 6 times x, which is 6x, and my denominator will be 15x times x, which is 15x squared. By doing that, we now have that common denominator that we want. So I have 6x plus 21 over 15x squared, and this would be considered the simplified version. Okay? So this is like an easier problem, but it's going to follow the general template for what we're trying to do. We're trying to create that common denominator by multiplying by some form of 1. After we have that common denominator, we can combine our multiple terms into one single expression. Okay, here is our next problem. Now, this is kind of a tricky problem, but I like it, because you're saying, all right, I want to create this common denominator, but these denominators are already very simple. Like, what can I do here? And so as you're looking at this, I'm going to kind of recopy it and give us a little space. H over h plus 2 plus 8 over 2 minus h. And what I'm going to do here is to help us see something, I'm going to write this in a different order. Instead of 2 minus h, I'm going to write that as negative h plus 2. And hopefully by me writing that, we can see the similarities between that denominator and that denominator. And what you see maybe just with experience over time is that if I were to take this denominator and I were to multiply it by negative 1, I really just need to change the signs of both of those. If I could turn that negative h into a positive h, we're good. And if I could turn that positive 2 into a negative 2, we're good. So what we can do here, and there's other ways to think about this, but the way I'm going to think about it right now, is the form of 1 I'm going to multiply by is a negative 1. Because now this is just anything over itself is 1, so that's just our fancy 1. And by doing that, what we create is we have h over h minus 2 plus, over here in our numerator, we'd have negative 8. In our denominator, I would distribute that negative 1 into both terms, and you'd have h minus 2, which now we've created that common denominator that we want, and we have our final answer. H plus negative 8 is just that. And then our denominator is h minus 2. There is the simplified version. Let's do another one. Now on this one, I believe this is our last example. Yeah, that's our last example. So right here, we are still trying to create that common denominator, but this one's just going to get, it's not going to get super gross, but so I'm going to recopy everything with space real quick, so let me do that. And so I've just kind of recopied our problem with some space, because our fancy 1 is going to look a little different this time. And you might be saying, oh man, what's our common denominator going to be? This denominator looks completely different than this denominator. And so what we can do is think, okay, in this situation, it might be easiest to create a denominator that has all 4 of these binomials in it. And let me show you what I mean by that. Over here on the left, this denominator doesn't have this x plus 3, so I'm saying let's put it there. Let's multiply by x plus 3 over x plus 3. This denominator over here now has the x minus 1, the x plus 2, and the x plus 3, but it doesn't have the x minus 4. So why don't we also multiply by this fancy one of x minus 4 over x minus 4. And then what we've done is we've created a common denominator, or we're halfway to creating a common denominator of x minus 1 times x plus 2 times x plus 3 times x minus 4. That's a big gross denominator, but it will be common by the time we're done with this. Now, let's do the same thing to this second value over here, because what it's missing in its denominator is the x minus 1, and it's missing the x plus 2. So what I'm going to do first is I'm going to get the x minus 1 over there, and then I'm going to get a new color. How about yellow? Let's see if we can see this. And we're going to do x plus 2 over x plus 2. Hopefully that's not too hard for you to read. And so by multiplying by these versions of the fancy ones, I kind of saw what was in the denominator here and used those to make our fancy ones for this part. And then I looked at what's in our denominator here and used it to make our fancy ones for this part. And now what you'll see is I've got a big old denominator there and a big old denominator there, but those two denominators are the same. Okay? And so what I'm going to do is I'm going to copy down what we have so far. We have this. And so we've got this, which is pretty much our answer. I'm going to kind of come over here to the right. What we could do, and I could kind of keep my denominator the same here. I'm going to have my x minus 1, my x plus 2, my x plus 3, and my x minus 4. So if it were me, I would probably want you to simplify this numerator a little bit. If I were to distribute those together, then distribute the 3 into that trinomial, and then distribute these two or kind of multiply these together with FOIL, and then distribute that negative 1 in. After that, you combine your like terms, and you should get this: 2x squared minus 4x minus 34. I'd probably prefer that as an answer, or even if you factored a 2 out of that, you could end up with 2 parentheses x squared minus 2x minus 17. So the format of our answer, I'm not wanting us to get kind of hung up on. I more want us to look up here and recognize how when you have a problem that's set up like this, what is your common denominator? And your common denominator is going to have all 4 values in this situation. If you can recognize that and recognize what your fancy ones should be, to achieve that common denominator, you should be good to go.